Hello, welcome to this class. We are still talking about energy, and for this particular class, we're talking about energy changes in an oscillating body. Energy changes in a body that is undergoing a to and fro motion. So, welcome to this class. Please, if you have not subscribed to our channel, please click on the subscribe button, click on the notification button, give us a like, and then you can reach us through the WhatsApp number that is showing on your screen. This is Normal Science Tutors Online, and I remain Otto Michael. So for this class, get your writing materials ready so that we can go straight to the class. As I said, we are discussing energy changes in a body that is undergoing a to and fro motion or oscillatory motion. Okay, so let's go to the class. One object that undergoes to and fro motion is a simple pendulum, right? It's a simple pendulum. So we are looking at energy changes when a simple pendulum is displayed through a small angle. When it is displayed through a small angle, you know that if you displace a pendulum bulb through a small angle, there will be energy changes. So when a simple pendulum is displayed through an angle and allowed to oscillate about its rest position, the following energy changes takes place. Now take notes. At the point B and A, the energies at point B and A, they are the same. At point O, the energy is different. So at point B and A, the energy of the pendulum bulb is equal to the potential energy, because at these 2 points, the bulb is at rest. So at this point, energy at this point is equals to potential energy. At this point, kinetic energy is equals to 0. Kinetic energy is equals to 0. Is that okay? Because here velocity is equals to 0. At this point, velocity is equals to 0. This is the point of maximum height. So energy here is equals to potential energy, which is mgh. Kinetic energy here half mv squared equals to what? 0. Okay, so please take note of this. Now, the same thing that happens at point A, that is what also happens at point B. Energy at point B is equals to potential energy. Kinetic energy is equals to 0, because at that point, velocity is equals to 0. I hope you take note of that. Now, at point O, the object has maximum velocity. Velocity is equals to V. So, which means at this point, it has maximum kinetic energy. So, here, kinetic energy is equals to half mv squared, and potential energy at this point is equals to what? 0. Potential energy at this point is equals to 0. So this is what I have we've written down here. At point O, velocity is maximum, kinetic energy is maximum, and it's equals to half mv squared. Potential energy is 0 at point O. At point B and A, potential energy is equal to mgh, kinetic energy is equal to 0, because velocity is equals to 0. So these are energy changes that takes place in a body that is undergoing simple harmonic motion or oscillatory motion. Another body that can undergo simple harmonic motion is a stretched string. A stretched string. So this is an example of a stretched string. When a loaded string at rest is stretched through a short distance downward, so assuming this string is stretched through a short distance, what is the energy that takes place when it is stretched? And you know, when you stretch a string and you releases it, it will now undergo a to and from up and down motion. It will go up and down, right? So what is the energy change that takes place? Just like in a simple pendulum, at point A, velocity at point A is equals to 0. At point A here, velocity is equals to 0. So the kinetic energy at this point is also equals to 0. At point A, kinetic energy is equals to 0. So the energy that the body possesses at point A is equals to potential energy. Potential energy at that point is equals to mgh. It's equals to mgh. And that is what we have here. At this point A, velocity is equals to 0, potential energy is equals to mgh, which is equals to half ks squared. This is the extension of the string. Okay, so when we are going to discuss Young modulus and elasticity of material, we're going to discuss more on this formula, right? So at point A, kinetic energy is equals to 0, potential energy is equals to mgh. At point B, there you have the point of maximum velocity, just like in the simple pendulum. So here kinetic energy is equals to mv squared and potential energy is equals to 0. That's at point B. At point B, potential energy is equals to 0. PE equal to 0. Kinetic energy is maximum at point B. Then at point C, kinetic energy is equal to 0 and potential energy is equal to mgh, and that is it here. Potential energy is equal to mgh. So please take note of these energy changes, because these are questions that you can be asked in your physics, especially in objectives. That's okay. These are questions that you can be asked. So please take note of these energy changes that takes place in a body that is undergoing simple harmonic motion or to and fro motion. That okay? So take note of all this. Take note of them. We also look at work done by an inclined plane. This is very, very key and important. I have to bring it up. Now, for a body that is rolling down an inclined plane, we know that the force on the body is equals to the weight components down the plane, which is equals to mg sine theta. So the work done will be equals to mg sine theta times the distance traveled by the body that is rolling down the plane, and the distance traveled is the length of the plane. So the work done will be equals to the first component down the plane times the distance traveled, and that is what we have here. So this is the equation for the work done by an inclined plane. First component down the plane times the distance covered by the object. So it's as simple as that. Is that okay? So I want to solve some problem now to drive home what we just discussed. An object of mass 50 kg is placed on a plane inclined at 30 degrees to the horizontal. The height of the plane is 250 centimeters and the length is 500 centimeters. Calculate the work done on moving the object down the plane. Okay, so that is what we just discussed now. I think this problem just depicts what we just discussed now. Please pardon me, my drawing might not be too perfect, but I just want to represent something like an object that is on inclined plane. Okay, so this is the object and this is the angle of inclination of the plane. Sorry, then this is the height of the plane, and then this is the length of the plane. Okay, so as discussed, the first component down this plane is mg sine theta. That's the first component down the plane. The force that is pulling this body down is mg sine theta. This force covers the distance L or S, as the case may be. Okay, so in this category question, you are given that the mass of the body is equals to 50 kg. The height of the plane is equals to 250 centimeters, 250 centimeters. So convert this to meters. So divide by 100, so that you have 2.5 meters. The length of the plane, which is distance, is equals to 500 centimeters. So you also convert this to meters. So this gives you 5 meters. Okay. So here you have a right angle triangle. Okay, and we say that work done is equals to what? Work done is equals to force times distance. Now the first component down the plane, we said is sine mg sine theta times the distance. The angle of inclination is given to us to be equals to 30 degrees. That is angle theta is equals to 30 degrees. So the first thing that you have to do here is for you to find, okay, here you have already been given the length, so you already know the distance traveled. So what you are going to do here now is to substitute these values into this equation. Okay, so that work done, the first component that the plane at distance mg is 50 times 10 times sine theta sine 30 degrees equals to 0.5. Can punch that out from your calculator, then times distance traveled, which is equals to 5. So if you work all this out, you are going to have 1250 joule. 1250 joule. So this will be the work done in moving the body down the plane. This is the work done in moving the body down the plane. So it's, when you understand what to apply, it becomes that easy for you to solve. Right? So that is it. This is a test question for you. Please just solve this one. A simple pendulum has a potential energy of 500 joule at the point of maximum displacement. If the mass of the pendulum bulb is 20 gram, what will be the displaced height? So remember that at that displaced height, the kinetic energy, the kinetic energy is equal to 0, and the energy that the body possesses due to the height is equals to potential energy. So if you remember that, you can easily solve this problem and get the displaced height. So test your understanding, solve this problem. You can post it on the WhatsApp number that will be showing on your screen shortly, or even on the comment section. That okay? So that's where we are stopping our class for now. Thank you very much. So please, if you have not subscribed to our channel, please subscribe to the channel, give us a like, click on the notification button so that when we upload a new lecture, YouTube will notify you. Also, you can reach us through the WhatsApp number that is showing on your screen. This is physics class direct to your doorstep. Invite your friends, give us positive comments. You can also give us some suggestions too on how to improve in what we are doing. This is a project that is ongoing, and we hope to give you the best in learning when it comes to physics. So thank you, and we hope to see you in our next class. Thanks.